Okay, so this is MA2006, tutorial 4 of week 5. I'm your peer tutor for this semester. Okay, so let's get started. So we have a vector equation. So show that this side is equal to this side. Okay, and the hint here is that let u be some vector containing ai plus bj plus ck. Okay, where I and j, k are the unit vectors. I, j, k are unit vectors. Okay, and v is also another vector with components p, q, r, and the I, j, k components. And also w is yet another different vector. Okay, so what we're supposed to do is evaluate the left hand side. Okay, this is the left hand side. Evaluate the right hand side, and show that they will be equal. Okay, so let's get started. So on the left hand side, we have u cross v cross w. Okay, so let's evaluate this one by one. First, let's find u cross v. Okay, to find the cross product of two vectors, okay, what you need to do is find the determinant of this structure. So the structure that I'm talking about is, okay, you put ijk first, and then the first row contains the components of vector u. The second row contains the components of vector v in that order. Okay, you cannot have. So this must contain the components of vector u. This must contain the components of vector v. It cannot be the other way around. Okay, so the components of u are a, b, c, and then the components of v is p, q, r. Okay, so how do we evaluate the determinant of this matrix? To evaluate the determinant of this matrix, so wait, let me put this down first. Okay, so what we're doing is we are finding vector u cross vector v. Okay, so to evaluate this, what you need to do is the Sarrus rule. Sarrus rule. Okay, Sarrus is a French mathematician. Okay, I call it the crisscross method. Okay, the crisscross method is to help us find determinants. So find determinants. But this only works for 3x3 determinants. Okay, other matrices, other square matrices cannot work. This only works for 3x3 matrices. So how does the crisscross method work? Okay, very simple. What you do is first copy down the first two columns. Okay, copy down the first two columns. I, J, A, B, P, Q. Okay, next we need to make the crisses. So the criss is in this direction. This, and this. Okay. What we need to do is we need to take the product of all the terms under each line. Okay. Take the product of all the terms under each line. So I times B times R is BRI. Okay? BRI. Followed by this J times C times P is CPJ. Then K times A times Q is AQK. Okay? So next we need to do the crosses. This cross. So the crosses is in the opposite direction. So this, and this. Okay? So let me just bring this to the side. What we need to do is we take this minus the crosses. Okay, so the same thing. You take the product under each line, the product of the terms under each line. So J times A times R is ARJ. plus I times C times Q is CQI. Then K times B times P is BBK. Okay, notice that I always put the unit vectors at the back. Okay, these are the unit vectors. They are vectors with magnitude of 1. Okay, pointing in the X, Y, and Z direction, respectively. IJK refers to the X, Y, and Z unit vectors. Okay, so now what we need to do is we need to simplify this. And how are we going to simplify this? We put the like terms together. Namely, this I and this I component, I'll put them together. Then this J and this J component, I'll put them together. And this K and this K component, I'll put them together. So namely, we got BR minus CQ. Okay, don't forget to expand this negative sign to each term. I plus, okay, now the J terms, CP minus AR J, and then now the K terms, AQ minus BP K. Okay, so this is our cross product. So I'm going to say again, when we're taking the cross product of two vectors, we want to find the determinant of this matrix. Namely, you put IJK first in the first row, the entries of vector u in the second row, and the entries of vector v in the third row. Then we use the crisscross method. So first thing first, you copy down the first two columns. Then after that, you need to find the crisses and the crosses. Okay, so the criss means I take the product of these terms, these terms, these terms, minus away the sum of the crosses. So these terms, these terms, these terms. Okay, so in essence, right, the determinant can be found by the sum of criss products minus the sum of cross products. Okay, so that's the shortcut of doing the 3x3 determinants. But we're not done yet. So we already evaluated U cross multiplied by V. Now we have to take what we got from earlier and cross product it with vector W. Okay, so that means we take our result here and then cross product with W. So same thing, to find this cross W, you copy down the result that we got. Sorry, first put IJK. So I, J, K, and then followed by what we have here. So BR minus CQ, then CP minus AR, then AQ minus BP. Okay, then in the third row, we put in the entries of vector W, namely STU. STU. Okay, so now we need to find the determinant of this 3x3 matrix. To do that, first thing first is you copy down the first two columns. Okay, and then you attach it to the right. Next, you need to do the crisses. So criss, criss, criss. Then you find their products. So you take, you multiply them up. So this, we have to multiply to these two terms, here and here. So CPU minus ARU I plus, again, okay, now the J component. So we have AQS minus BPS J plus BRT minus CQT K. Okay, now we have to subtract this away, subtract the cross terms. Okay, so now we have to go to the other direction. So like, oops, sorry. Like this, and like this. Okay, So you multiply all the terms under each line. So let's start from this line. And don't forget, you need to just expand them. So u times br minus cq. So we have bru minus cqu j minus aqt minus bpt. This is k, right? Sorry, I. Then minus, okay, last one, cps minus ars. Okay. Okay, so now we have to simplify by adding all the like terms together. Mean is the I component with the I component. So I'm going to straight away expand this negative sign. So we have CPU minus RU minus AQT plus BPT. Then followed by the J components, this and this. Again, I will expand the negative signs already. Plus AQS minus BPS minus BRU plus CQU J. And then lastly, the K terms, this and this. Again, don't forget to expand the negative signs out. So we have BRT minus CQT minus CPS plus ARS K. Okay, so this is our result from the left-hand side. So this is the left-hand side. Now we're going to do this, a similar thing with the right-hand side. So we're going to independently work out the right-hand side and check if they match, if these two results match. So we're going to have to keep this result in view first and then check it later. So now we want to deal with the right-hand side. So the right-hand side states u dot w, okay, let me check that again. U dot w, let me just copy this. Okay, so u dot w, and then you multiply that with the vector v. So vectors, okay, the vector u is ai plus bj plus ck, and w is what? Forgot. stu. S T and U. Okay, so you can write vectors in this form, in IJK format, or you can also write them in column vectors as brackets. Okay, so meaning to say, U can also be written as this, A, B, C. Okay, so the first entry is the I entry, the I component. The second entry is the J component, and the third entry is the K component. There's equivalent things just written in different forms. Okay, and it doesn't matter if you use square brackets or round brackets, A, B, C. That's totally fine too. Okay, so without further ado, let's go ahead and do this question. Okay, so usually when I do dot products, it's easier to write them as brackets. Okay, as column vectors. So instead of writing as AI plus BJ plus CK, I'm gonna write this as ABC dot W was STU, right? And then later we'll multiply this with vector V. Okay, minus, so vector V was PQR, right? Yeah, correct. Okay, PQR dot S was W was STU. Then later we have to multiply this with vector U. Okay, so let's evaluate the dot products first. Okay, namely this and this. So dot product, very simple. The definition of dot product is you multiply the corresponding entries and then add up these together. Meaning you say A times S plus B times T plus C times U. So it will be AS plus BT plus CU will be this. Minus, okay, same thing with here. So multiply the corresponding entries and then add them all together. PS plus QT plus RU. PS plus QT plus RU. Okay, so now we need to substitute the expressions for V and U in. Okay, got this. For that, great. I'm gonna straight away substitute this. Namely, okay, I remember U is AI plus BJ plus CK. Okay, and then vector V was what? PQR. PQR. Let me move this aside first. P Q R I J K. Okay, so now we need to expand and simplify. So what I'm gonna do is I'm gonna focus on the I components first. Okay, we're gonna expand this, but I'm gonna focus on the I components, meaning I take this times this, followed by this times this, followed by this times this. Okay, just concentrate on the I components first. So if you do that, you get APS plus BTP plus CUP, and then this whole thing, don't forget you have a unit vector. Okay, then do the same thing with the J component this time. Meaning you say this, this, then this. Okay, so it'll be ASQ, ASQ followed by BTQ followed by CUQ, J. Okay, then next we have what? We have the K components. Okay, you expand it again for the K components. So CUR, sorry, start with this. So let me just say it. Maybe this times this. ASR plus BTR plus CUR K. Okay, now I'm gonna do this side. So we're gonna do the same thing. We're gonna expand first the I components, then the J components, then the K components. Okay, if you do that, you will have so APS I minus BQT. Sorry, I need to focus on the I terms. So minus APSI minus AQT. Let me work this out. This, and then followed by this. Okay, don't forget you already expanded the negative into here. So every term will have negative. So negative APS. This looks like a Q, right? Negative APS. Negative AQT. And then negative ARU I. Followed by, okay, now the J components. This times this times this. So let me just pull out my solution. Okay, my solution states negative BPS minus BQT minus BRU J plus, now we do the K components. So minus CPS minus CQT minus CRU. Okay. Okay. So next we want to simplify. So let's take a look at the I components. We're gonna add up the I components. Okay, namely this one and this one. See if there is anything that can cancel out. And there happens to be some things that can cancel out. Okay, so take a look at here. Inside the brackets, right, we have positive APS minus APS. So they can cancel to become 0. This minus this. And that's it. That's all we can simplify. So we just group all the items together. So group this with this. Okay, so we have PTP plus CUP minus AQT minus ARU. I. Then next we have the J terms. So look at the J terms. See if there's anything that can cancel. And yes, there happens to be something you can cancel, right? BTQ is the same thing as BQT. So BTQ minus BQT becomes 0, and there's nothing else you can simplify. So we'll just add up the terms together. ASQ plus CUQ minus BVS minus BRU. J. And lastly, we have the K term. So see if anything can cancel. And yes, CUR minus CRU. Same thing. Then you add up the components together. So just group them all together. ASR plus BTR minus CPS minus CQT. Okay. Okay, now we check the two results that we got. So this is our right-hand side of that equation. Check if they're the same. So let me go back up. I'm going to copy this so that we can see them side by side and check if they match. Hopefully it should. So this is the result that we got from our left-hand side. And let's check the I components first. Okay, namely this one and this one. See if they exactly match. Okay, CUP, CPU, minus ARU, minus ARU, minus AQT, minus AQT, BTP, BPT. Okay, now followed by the J components, ASQ, AQS, minus BBS, minus BSP, sorry, BPS. Then CUQ, CQU, minus BRU, minus BRU. Okay, great. Then we look at the third component, ASR, ASR, ARS, BTR, BRT, minus CQT, minus CQT, minus CPS, minus CPS. Excellent. So left-hand side is equal to the right-hand side. Therefore, we have proven the vector identity. Okay, so we can move on to the next equation. Sorry, next question. Next question says, with reference to a coordinate system OXYZ, so in 3D space, find a plane that contains these three set of points. Okay, so let's call these points A, B, and C. So what the question is saying is, we want the equation of the plane that contains these 3 points. This, and this, A, B, C. Okay, a plane is thought to be like a sheet of paper. Okay, a black sheet of paper. Okay, a plane is, by definition, is a flat surface which extends infinitely. So it's not just a little rectangle like this. It extends infinitely out. Okay, so that's the idea of what a plane is. Okay, and namely on this plane, we need the 3 points, namely A, B, and C, which are labeled here. Okay, so the hint is, one way of doing this is to find 2 vectors on that lies over here, blah blah blah. So let me just show you how to find the equation of a plane. Okay, for any plane in 3D space, okay, the form of a plane is like this. Okay, n hat dot x minus x naught, y minus y naught, z minus z naught is equal to 0. This dot is dot product. Okay, is the vector operation dot product. So this will help us, by remembering this will help us tell what are the ingredients to a plane. Namely, this, which is the normal vector, and x naught, y naught, z naught. Okay, x naught, y naught, z naught is a known point on the plane. Okay, now there is an intuitive logic behind why these 2 ingredients are important to define the equation of a plane. Okay, So the idea is this. Let's go back to thinking what defines the equation of a straight line in 2D space. Y equals to mx plus c. You know that you must have two things, the gradient and the y-intercept, right? Because, let's see in 2D space, the gradient will control how much it slants. Okay, how much it slants. So, like this is one gradient, like this is another gradient, like this is another gradient. And then, the y-intercept fixes the position of the straight line. Why? Because let's say I have this straight line, which has a gradient of 2, okay, m equals to 2. But then I can also have this straight line, which also has a gradient of 2. They're both parallel. Okay, so how do you define the equation of line? They both satisfy that the gradient is 2. So to find the equation of line, you must fix the y-intercept. So I want c is equal to 2. Therefore, it's like that. Okay, and this could be a different value of c. Okay, so those are the two ingredients for a straight line, namely the gradient, so how much it slants, and then the y-intercept, which fixes the position of the straight line. And it's a similar thing for planes. Okay, so for planes, you need at least one point on the line, okay, which is given by this coordinate. Okay, so we have one point here, and the plane must contain that point. Okay, the plane must contain that point. But then, if I don't have the normal vector, right, there could be a different plane which also contains that point. Okay, which also contains that point, but it slants in a different direction. You see, both of these, plane 1 and plane 2, both contains this known point. However, they slant in different directions, so they're different planes. So in order to control the orientation of the plane, right, you need a normal vector. Okay, a normal vector, normal means perpendicular. Normal means perpendicular, 90 degrees. Okay, 90 degrees to what? 90 degrees to the plane. So a normal vector will look like this. If I give you a plane, a normal vector would be sticking out of the plane 90 degrees to the surface of the plane. Okay, you understand? So this is the normal vector. It controls the direction, the orientation of the plane. Because okay, let me get out my plane. Okay, say that this is a plane. Okay, so in order to control its orientation in space, we put a normal vector, a vector that's 90 degrees to the plane. So this acts as a pointer that helps the plane point in a certain direction that we want. Okay, so long story short, those are the two things that you need to find the equation of a plane, namely the normal vector, and any point on the plane. Okay, any point on the plane. Yeah, and don't forget to remember this general equation of a plane. So the ingredients to find the equation of a plane is number 1, the normal vector, and then number 2, a known point on the plane. Known means the coordinates are known on the plane. Okay, and two concepts you need to know. Okay, two concepts that are important for you to know is that. Let me just write this down. Two concepts that you need to know is that number 1, the dot product of two perpendicular vectors is 0. And number 2, the cross product of any two vectors, okay, it doesn't have to be perpendicular, it's of any two vectors is perpendicular to the two vectors. Okay, so let me explain. Dot product of two vectors, of two perpendicular vectors is 0. So these two vectors that we are considering here are 90 degrees apart. If they are 90 degrees apart, let's say I have A and I have vector B, and they have an angle of 90 degrees. Okay, we know the definition of dot product A dot B can be given by the formula A, magnitude of A, magnitude of B, sine, sorry, not sine, cos theta. Okay, and if they're 90 degrees apart, that means we change this to 90 degrees. And if you evaluate this, cos 90 will become 0. So since they are 90 degrees apart, we know that the dot product is 0. Okay, this is an important concept for you to know, that if you have two perpendicular vectors, you take the cross product, it's definitely always 0. Okay, then moving on, the second point. The cross product of any two vectors is perpendicular to the two vectors. Okay, so if I have any vector, okay, vector A and vector B, okay, doesn't matter what angle is between them, doesn't matter. Their cross product will be a vector that is perpendicular to both of them. Like this and like this. See, they're both 90 degrees away from A, 90 degrees away from B. Okay, so this vector is A cross B. Okay, that's all you need to know. Okay, so yeah, okay, we can start. So we want to find the equation of the plane containing the points A, which is given by 213, B, which is given by 302, and C, which is given by negative 1, 1, 4. Okay, so let's recall what we need. First, we need the normal vector. Second, we need a known point. And we can choose any point, right? I can choose B, I can choose A, or I can choose C. Doesn't matter which point that we choose. So we have a known point already. Known point. So this is settled. Now we need to find the normal vector, which is a vector which is 90 degrees to this plane. Okay, 90 degrees to this plane. So how do we do that? Okay, we need to do a bit of math. First, I want you to find two vectors that are in this plane. Two vectors that are in this plane. Okay, so let's say we want the vectors AB and AC. Okay, so how do we find AB and AC? Okay, to do this, we need to express AB and AC in terms of its position vectors. Okay, which is the formula that we've seen before in secondary school. Namely, if I give you a vector AB, it can be written as OB minus OA. Okay, this is called expressing a vector in terms of its position vectors. These are the position vectors. Okay, any point, right? Let's say I give you a point Z. OZ will be its position vector. If I give you point X, then OX is its position vector. Okay. So now if I want you to write AB in terms of its position vectors, it'll be OB minus OA. It's not OA minus OB. It's OB minus OA. This comes from the triangle law of vector addition. But never mind that. You just simply remember AB is given by OB minus OA. It's the second letter minus OA, the first letter. So if I give you vector CD, writing it in terms of position vector would be OD minus OC. If I give you EF, it'll be OF minus OE. This is what you call writing it in terms of its position vectors. Anyways, let's continue. So the position vector is very easy. The position vector, right, is just the coordinates of that point, but you change it into a vector. So see, point B has the coordinates 302. Then that means OB is given by the vector 302. Like that. Then OA, so A has a coordinates 213. Therefore, its position vector will be 213. Okay, then we calculate this. 1 minus 1 minus 1. And this will be our vector AB. Now we want to find the vector AC. Again, you write this in terms of its position vectors, namely OC minus OA. Then you go find its coordinates. So OC is given by the coordinates negative 1, 1, 4. Therefore, its position vector will be negative 1, 1, 4. And OA, we already saw, is 2, 1, 3. Okay, calculate this. It will be negative 3, 0, 1. So this is AC. Okay, so finally we have found two vectors which are in this plane, namely AB and AC. So how do we get the normal vector? Recall from this concept that the cross product of two vectors will give you a perpendicular vector, right? So now that we find AB and we find AC, to find a vector that's normal to both of them, you just take AB cross AC, okay? And that will give you this vector. So this one is AB cross AC, okay? So that's why we need to know that cross product will give a vector that is perpendicular to the two vectors. So find AB cross AC, okay? So 1, -1, -1, cross -3, 0, 1. So remember, to find the cross product of two vectors, we need to find the determinant of this structure, I, J, K. So in the first row, we have the components of AB, -1, -1. Then second row, we have the following row, we have components of AC. Okay, do the crisscross method, copy the first two columns. And then we do crosses and crosses. Criss, criss, criss. So -1i, sorry, -1i. Then this is +3j. Then thankfully there's 0k, so we don't need to write that. And then minus away the sum of the crosses. So this times this times this. So we have 1j, 1j. Thankfully there's 0i, so don't need to write that. And then +3k. Okay, then we just simplify by grouping all the like terms together. So we have -i. Then this is 3 minus 1 is 2. Then minus 3k. So let me check my answers. Okay, so far so good. So this will give us the normal vector to the plane. Okay, so now we can finally build the equation of the plane, namely n dot x minus x naught, y minus y naught, z minus z naught is equal to 0. So the normal vector is this. Okay? Let's express it as -1, 2, -3. Okay, I write it as a column vector. And then choose any point on the plane. For discussion, I will choose the point A. Sorry, I chose the point B. Okay, you can choose A also. It doesn't matter. Doesn't matter. It will give you the same thing. So I put in x, y, z. The coordinates of B is 3, 0, 2. Okay, to find the dot product, you multiply corresponding entries. This time this, plus this time this, plus this time this. So if you do that, I'm going to straight away do it. Okay, then I'm going to put them in the form of ax plus by plus cz is equal to d, where d is a constant. If you do that, you'll get x minus 2y plus 3z is equal to 9. Okay, so that's our second question done. Sorry, we still have b. So this question B state, a straight line perpendicular to the plane passes through the point this. Find the parametric representation of the straight line. Okay, the parametric representation of any straight line is given in this form. Okay, so let me tell you, the general form is this. So equation of a straight line is given by, so this is the x, y, z on the line, on the straight line. X naught, y naught, z naught. Just like earlier, this is the known point T, A, B, C. Okay, so let me tell you what this is. This is a known point. Okay, you know the points, the coordinates of a point on this line, known point. What's this? This is a vector which is parallel to the line. Okay, a vector that's parallel to the line. T is called a free parameter. Okay, T is called a free parameter, which is a point that you can vary to find all the points on the line. Okay, so I'll tell you what I mean later. But first of all, let's solve this question first. Okay, so we know the point that it passes through, right? They say in the question that it passes through negative 2, 5, 2. It passes through negative 2, 5, 2. So we already got this. What is the vector parallel to the line? Let's take a look. Okay, let's take a look at the diagram. It says that this straight line, right, is perpendicular to the plane. Perpendicular to the plane, doesn't that look like the normal vector? Remember, we have found the normal vector of this plane. We have found it to be, what is it? Okay, we found it just now from the cross product is negative 1, 2, 3. Okay, we found it from earlier. Let me just show you this one. Okay, so we know that normal to the plane is this vector, and you see this normal vector is parallel to the straight line. Therefore, we've already found this, which is this. Okay, so now we can fill in the formula x, y, z is equal to negative 2, 5, 2 plus t times negative 1, 2, 3. And that's it. You can just leave it like this. Or if you want to simplify it, you can go ahead and add up the corresponding entries. But you can stop there already. 5 plus 2t minus 2.3t. Okay? Yeah. So what is this free parameter? You can think of it like a dial. Okay? What I mean by a dial is like a knob that you can turn. You know, like when you adjust the volume of a speaker, there's a dial you can turn, right? So I want you to think of t like that too. So you can point from t equals 0, and then it can take on any value. Like for example, t equals to 50 or t equals to 100, whatever. You can even take on negative values also. Whatever. There's infinite values of t. Yeah. So as you tune the value of t, right, what you're doing is you are moving along the straight line. So maybe here t equals to 1, and then it will calculate you a set of points x, y, z. X, y, z. And then when you move t into the value of 2, it will calculate you another set of points, x, y, z. But with a different value, of course, x, y, z. And then, yeah, you can just keep doing this. You can keep moving t around, and then what it will do is just make you travel along the line. Okay, so that's what I want you to think of t as. It's like a knob that you can turn to vary your position along the straight line. Okay, yeah, so that's the parametric equation. Yeah, it's because of this free parameter, right? Parameter. That's why it's called the parametric equation. Okay, so let's move on to the next question. The next question states what? Find the point where the plane in part A meets the line at part B. Okay, so where two objects intersect in space, right? That means the coordinates are the same. So this is the plane that we derived earlier from question A, and this is the straight line that we got from part B. Okay, they intersect at this point, right? So that means they share that coordinate. And we have already found that the equation of this plane is what? The equation of this plane is x minus 2y plus 3z. And we have also found that the equation of this straight line is given by this, right? X equals to negative 2 minus 2, negative 2 minus t, y equals to 5 plus 2t, and z is equal to minus 2 minus 3t. So what we need to do is we sub those in, okay? Let me just write down this. Okay, sub the equation of the straight line, namely x, y, z is equal to minus 2t, 5 plus 2t, 2 minus 3t, into x, 3z equals to 9. Okay, so that means this, I sub it into x. This, I sub it into y. And this, I sub it into z. Okay, because they share the same point at the point where they intersect. Okay, so minus 2 minus t, minus 2, 5 plus 2t, plus 3 minus 2t is equal to 9. Okay, you can expand and simplify, make t the subject, and you'll get negative 27 over 14. Okay, once you found this t, right, you go back to your straight line equation, and then you sub t is equal to minus 27 over 14 into here. Then you can calculate the coordinates. Okay, so sub this value of t equals to negative 27 over 14 into the straight line equation. So if you do that, you have this 27 over 14, 5 plus 2 times negative 27 over 14, then minus 2 minus 3 times negative 27 over 14. Yeah, and then you will get the coordinates. Okay, the coordinates that you will eventually get is this, and this. Okay, so yeah, that's how you solve this question. Then lastly, we have question 3. So what does question 3 state? Question 3 states, find all magnitude vectors perpendicular, okay, keyword is perpendicular to I minus k. Okay, the hint is that you let that general vector be A, B, C, and form a linear equation this. Okay, so they said, right, it is perpendicular. So A, B, C is perpendicular to I minus k. And then recall from earlier, what did we say? We said that for two perpendicular vectors, right, the dot product must be 0. Okay, remember that. Dot product of two perpendicular vectors must be 0. Dot product of two perpendicular vectors must be 0. Dot product of two perpendicular vectors must be 0. So that means if we take the dot product of this and this, it must be equal to 0 for it to be perpendicular. So let's go ahead and do that. So A, B, C dot this written in the column vector form, right, will be 1, 0, minus 1. You see there's no j, right? So it will be 0 in the j entry equals to 0. And then, okay, so you multiply the corresponding entries, add them up. This time this time this, plus this time this. A minus C equals 0. Then this, right, will help you satisfy the fact that the vector is perpendicular to I minus k. Okay? So how do we solve this equation? To solve this, right, let's express it in augmented matrix form. Yeah, let's express it in augmented matrix form. Don't forget, we have three unknowns, A, B, C, which are the components of this general vector, right? So remember, if I have it in augmented matrix form, okay, this matrix, let's form a matrix equation first. By the way, this is a zero vector. This matrix contains the coefficients of the unknowns. The unknowns are A, B, and C. Okay, the coefficient of this is 1. Then there's no B, right? So it should be 0. Then here the coefficient is negative 1. But then we only have one equation, which is this one. So what happened to the other two lines? This line and this line. You can just put them as 0. So fill them all with 0. Because there's no equation. It doesn't show up. So just fill those entries with 0 and it should be the same thing. Okay? And then, yeah, this should be 0, 0, 0. Oh, sorry. I made a wrong statement. Yeah, it should be 0 here. Sorry. Okay. Yep. So now we can draw this in augmented matrix form. This is a matrix equation. Following a matrix equation, then we can write it in augmented matrix form. Maybe you just copy down this matrix. And then you copy down the constants. Okay, now to solve this, you check whether it's an upper triangular matrix form. Yes, because all of these are 0. Then you look from bottom to top. Okay, you solve from bottom to top. Okay, you focus on this first. This states 0z is equal to 0. Okay, so if this is the case, that means, sorry, not 0z, it's 0c, because c is the third unknown. This states that c is a free parameter. Okay, this is because when c, let's say for example, c is equal to 1, will this equation be satisfied? Meaning, will the left hand side be equal to the right hand side? And the answer is yes, right? Because 0 times 1 is still 0, which equals the right hand side. Let's think when c equals to 2. When c equals to 2, it'll be 0 times 0 is equal to 0, still satisfied. Then continue this until c equals to 1000, c equals to 1 billion. You notice that for any values of c, this equation will still be satisfied. Therefore, c can be any number. So we let c be equals to t, where t is a free parameter. Okay, then so equation 2 is useless. It doesn't tell us anything. Then you just substitute it into equation 1. So equation 1 is the earlier one that we got, a minus c is equal to 0. This is replaced with t. Then you solve for a, it will be this. Okay, so you see, equation 2 states a very similar thing. So instead of focusing on the z component, which already looked at, we focus on the y component, which is 0, 0b is equal to 0. And it's the same thing. So b can take on any value, right? So we let it be a different free variable. So let b is equal to s. Okay, so finally, we have our solution. See, this is a, b, and c, we let it be t just now. So a, b, c is equal to t, s, t. Okay, but this only satisfied one part of the problem. This only satisfied condition 1, which states that it is perpendicular to I minus k. The second condition they want us to satisfy is that it is a magnitude of 1. Let me just go back to here. It says how can you ensure that there's a unit magnitude? Unit magnitude means magnitude is equal to 1. It's very simple. So if you have a vector, right, you can change it to a unit vector by taking the vector itself. So the unit vector, sorry, don't need magnitude, just the unit vector. Okay, you take the vector itself. Let's write it in ijk form. I, j, k. Then divided by its. I gave you a vector a, b, c, right? Its magnitude will be given by square root of a squared plus b squared plus c squared, okay, which is basically Pythagoras theorem. So a squared plus b squared plus c squared, which is equal to, you can simplify this. I'm going to simplify it straight away. So t squared plus t squared is equal to 2t squared. Okay, voila. Okay, that's done. So that's tutorial. Sorry, was this tutorial 4? Not that. See you next week.